All right, example 3. You are standing in front of a large waterfall. You see a small branch begin to fall off the edge of the waterfall. You begin counting as the log drops, and you count 5 seconds as it falls to the lake below. If your uncertainty is roughly 0.5 seconds, how tall is the waterfall, and what is the estimated error in your calculation? So we're going to come back to our one-dimensional kinematics. So the position function, s of t, is our initial position plus our initial velocity times t minus, if our acceleration is all due to free fall, then this is the acceleration due to gravity, so minus 1/2 gt squared. Okay, now this is only for vertical motion. So if we think of this as our waterfall, the water comes this way. So it is true, as our little log, as the log here, as this flows, it does have this left-right velocity. But once it gets to here, the edge, we are only keeping track of the vertical motion. We're not keeping track of any velocity in the left-right direction, only up and down. So in this case, we're going to say that the initial velocity, where we'll say the initial velocity is 0 because it hasn't yet begun to fall. You know, when t is 0, that's exactly when it starts to fall. Okay, so its initial velocity vertically is 0. Horizontally, of course, it's not 0, but we don't care about that. So the initial velocity in the vertical direction is 0, and the initial position is the waterfall's height, which we are trying to figure out effectively. So let's go ahead and get started on this. So let's fill this in then. So using this information, we have s of t equals s naught minus 1/2 gt squared. So if we counted 5 seconds, this tells us when t is 5 seconds, we know that the log was on the ground, or not the ground, but the lake. So that means when when t is 5 seconds, s of 5 must be 0. It's reached what we're calling 0. So we're calling the surface of the lake 0 meters. So we can fill this in. So we have 0 equals s naught minus g over 2, 5 squared, so 25. So it appears that our initial height of the waterfall, s naught, is 25g over 2, which is about 122.5 meters. Now, what's the estimated error? Well, remember that the actual possible difference is estimated by ds. In practice, ds is usually much easier to calculate than delta s. So this is s prime of t dt. So we want to know this at our 5 seconds. And our dt is 0.5 seconds, so half a second. So s prime, let's for a second go ahead and get s prime. S prime of t is negative gt. So if we plug in 5, this is negative 5g over 2, which is approximately negative 24.5 meters. So essentially, based on our knowledge of how uncertain we are in our counting, the maximum difference in the height we could have, we found this to be 122, and we're saying, well, this might actually be 100. This could be 24.5 meters more or less. So this minus sign is talking about one specific direction, but when we think about an error, we can think about the error applying in either direction. We could have overcounted by a half a second or undercounted by a half a second.